Everybody, it's Tyler here at the Green Bay Hackers qualifier, checking in with 13-201 Team Hazmat. This team is top 100 on the FTC Scout, so hopefully you've been paying attention to this team. But if not, we're going to be showcasing an awesome robot for you. Already won a qualifier earlier this year, so congratulations on that. But we got a lot of great stuff to go through on this. Build quality, absolutely exceptional on this. But we're talking a lot about their autonomous roles, what they're doing for that, an initiative called FTC Wires, and a whole lot more. So let's learn more about this team. Come up here on Behind the Bot. Caleb, walk me through this awesome intake. Your team has been doing so well so far. Quick cycles as well, too. Let's learn more about it.
So our robot starts with the intake. We have a 2-bar linkage connected to our slides for a speedy extension. We have a triple articulated system on it consisting of an arm, wrist, and swivel. At the end of our swivel is our custom claw component. We have an integrated color sensor that allows us to auto-reject if we pick the wrong color. We have a V-guide in the front that allows us to better align the samples and grab with more precision. We have a sleek claw design that reaches into the divot, letting us grab adjacent samples.
So looking at that, what were some initial designs your team came up with, and how'd you get here?
One initial design we had for intake was we had a roller idea. We didn't go with this idea because drivers could accidentally commit a penalty with a roller, and we could see at this iteration board, our main focus was getting from bigger to smaller. We could see how bulky our initial design was with the claws. Then we made it smaller. Then we added the conveniences like a V-guide, and then the better claw. And then we made the V-guide to be smaller to finish the design.
So a great design overall for that as well, too. Let's talk about the outtake for what you're doing for that, Viraj, and the climber as well, too. I mean, just watching your last match, your team is just so quick on both those aspects. Your climber is super impressive, too.
Yeah, thank you. So as soon as we intake our samples, our color sensor detects that, and we have a auto transfer option available for us. So as soon as our color sensor detects that we have picked up a sample, it auto transfers and puts us in a position where we are able to do a quick transfer. The way our transfer works is by sandwiching the specimen or the sample. Our outtake consists of a arm and wrist, so that we can swing the arm out, and then our wrist can determine our drop. This same system also does specimen. So we have the specimen on the ground with the hook facing up, and our pass-through system allows it to be done without any turns. A lot of robots with this similar design use the outtake claw and grab it off the wall. But what we realized from this was that it causes too many turns because you have to be facing backwards when you pick from the wall, and then you have to turn 180 degrees to latch it onto the chambers. So we wanted to minimize these extra turns, which is why we opted to use our pass-through system to do that. As for our outtake, we use two 232 RPM motors. We initially had 435 RPM motors before we switched to an outtake claw. And at that point, we had an outtake bucket, and we had a separate specimen system. The reason we got rid of that is that we wanted to integrate a pass-through system where we didn't have to have that separate specimen system do any work. That also significantly reduced the weight off of our robot because there wasn't an extra U-channel, motor, claw, etc. on the robot. We used to have 435 RPM motors, but those didn't work out too well for us because we also opted to climb on these outtake slides. So as you can see here, we have two custom fabricated hooks attached to our custom fabricated plates. These hooks latch onto the high rung, and then they raise the robot up enough until our two plastic hooks here latch onto the low rung. This allows us a level 2 ascent, and it kind of minimizes the stress that we put on our motors because half of the weight is then being carried off of these. In the future, we plan on implementing level 3 ascent by adding slides here going out at an angle coming this way, where our outtake slides will be able to latch onto the low rung, and then these slides latch onto the high rung after we have completed a level 2 ascent to get to the level 3 ascent. We also want to involve some PTO into our design. As I said, our 232 RPM motors, while they allow us to climb, they are pretty slow in our outtake, and we lose a lot of time during cycling. So when we add a PTO system into our drivetrain, we can take advantage of the 435 RPM motors we have down there, and that can allow us to have a higher RPM motors up here and allow us to have more torque there.
Let's jump into the software a bit more, and there's a lot going on both from a software and software autonomous modes as well too. So let's run through software in general. How's your team approaching it so far?
So we implement Poke-Okie logic using a state machine combined with sensor input for maximized efficiency in transfer. This includes the 2 color sensors, allowing for automated intake from one click of a driver, giving us a really fast transfer time that you see on the field. Moving on, we also implemented bicubic dynamic acceleration, allowing for our drivers to use precise control on the robot, further increasing our chances to score more points. We also have custom vision extension based for our intake system, allowing for a much quicker intake from the submersible using OpenCV and a color locator using OpenCV libraries.
So after our qualifier and Frozen Frenzy, one thing we wanted to focus on was reducing time in autonomous period. And one way we did that was with the integration of splines. Using the Roadrunner Visualizer RR Path Gen, we figured out optimal splines to reduce time in the autonomous trajectories. And we also implemented parallel actions. Instead of moving the intake and then moving the robot, we decided to make those actions move in parallel. This led to a quicker auto time, reducing our time by about 5 seconds.
Rohit, talk to me about your FTC Wires initiative and what you're doing. I'd love to just hear more about what it is.
Yeah, so FTC Wires is an initiative we started for teams to just learn more about FTC and have be able to be better in FTC. So FTC Wires, you can go to ftcwires.org. We have software platform for Roadrunner and block coding to make every team able to use it. And then we also have business side of things, outreach, planning, and etc. like that. So it's definitely something you can check out at ftcwires.org or scan this QR code.
Always great to see what initiative FTC teams have brought to the table as well, too. Let's start to wrap up on this robot. Talk about what's actually happening on the field, how you're approaching match strategy, and everything else with that.
What we tend to do is that we want to go for like the samples in the high bucket. Because we did a game analysis and realized that we can score a lot more points with like the samples being in the high bucket. Because you can do a lot more and a lot quicker. So that means that we can have more points scored in the high bucket. Currently, we're able to get around 14 to 15 in the high bucket during teleop, with 3 to 4 during auto, giving us around 19 to 20 samples inside the high bucket, which allows us to score a lot of points. We're able to also do specimen with around 7 for teleop and around 5 for auto. So allows us to get 12 in the match. Overall, we're able to do really quick cycle speeds and score a lot of points, keeping our robot very efficient while also helping out with our alliance partner with all our adaptability and flexibility. We're able to do whatever our alliance partner needs us to do during a match, so it can be a reliable robot for any team.
Well, Team Hazmat, congratulations on all your success so far. We can't wait to see how you do here. Good luck at this qualifier and hopefully beyond as well, too. We can't wait to see you and your journey throughout the rest of the way. Thanks a lot, guys.
Thank you.